Hello, this is Schedulytics and welcome to today's session. In today's brief video, we are going to take a look at the survivor parametric models, which are based on the distribution of the data. So generally, we will be looking at the Weibull distribution, and we'll also be looking at the exponential distribution models of the survival analysis. In our previous video, we spoke about the Cox proportional hazard model, which today we are establishing that is a semi-parametric model that is used to establish the relationship between the survival time and the predictor variable that we are trying to predict their relationship with the outcome or the survival time. Also, the Cox proportional hazard ratio assumes that the hazard ratio are constant over time. But in today's video, we are going to talk about two kind of distribution model, which is the Weibull distribution and the exponential distribution. The Weibull distribution, for example, is of special interest to us because in this case, the hazard rates are variable and not constant over time. In situation where the hazard rate is constant over time, then we have to use the exponential distribution. So just have those two things in mind whilst we go on. So the code that we need to be able to run that is streg. So it's a regression. So we want to go to Stata to give us some information about it. So we type help streg, and here we have some information here. So you can click on this, and then you can have the PDF version of what we are having here downloaded for you to be able to have a glimpse of it. And so when we click there, we are going to see this information. So generally, it tells us that so it's a Stata survival analysis reference manual 16. So our interest is what? streg, which is this one, which is a parametric model. So here is a streg performs maximum likelihood estimation of the parametric regression. So what we're interested in is this. So it's a parametric regression. So you can take your time and read through all of that. Now, there are a number of survival models that can be run, or parametric regression models that can be run. We have the exponential, we have the Weibull, we have the log normal, log logistic, and so many others. So you may want to take your time, read through this document so as to abreast yourself with them. But for now, we are just going to demonstrate using the Weibull distribution and the exponential distribution. And we established that for the Weibull distribution, we want to see whether the hazard ratio is variable or constant. When it's constant over time, then you want to settle for the exponential distribution. So to be able to run, the code you need to be able to run that is streg. Then you type your variable. So we are interested in the sex of the child. We're also interested in the residence, I dot residence, and I dot emedic. I think we end there. Then we add distribution. So you can add dist or distribution in full. And then we type in Weibull. And we want them to present to us the base level. So we click on it, and then it starts running. There's iteration 7, and then we have our Weibull pH regression. So we give us a number of subjects, the number of failures, and then the time at risk or the person years, the number of observations. Then we have the likelihood ratio, and then the probability of the likelihood ratio or the chi-square test. And then we have the various hazard ratios and the corresponding standard errors, z-score, p-value, and the 95% confidence interval. So when you look through all of this, you realize that none of the p-values here is statistically significant. And so we can draw three conclusions from what we have in here. But our main focus is going to be on these values, this P and then the 1 over P values. Generally, if the P, so what we have here is 5.838 that. Generally, when you realize that this value is higher, then it means that this P will be lower. And the lower this is and the higher this one is, it indicates that the event of interest occurs relatively slower over time. But in the case where this is lower and we have this being higher, then it means that the event of interest occurs relatively faster. So in this case, the rate of death or mortality among these under 5 children is relatively lower because this value is a little low while this is high. So generally, this is how you can be able to run the Weibull distribution and be able to tell whether the rate of or the hazard rate occurs quickly or is slower. Now, for you to be able to run the exponential distribution, you just change the line of code and put here exponential, and you are good to go. So here it doesn't give us the P and then the 1 over P value because this can be used to establish the rate at which the hazards occur or the events of interest occur. So basically, this is how you can be able to run the Weibull distribution and then the exponential distribution using the Stata platform. Mind you, you fall for the exponential when you realize that the rates of hazard rates are constant throughout. But if you realize that the data you are dealing with, especially the biomedical data set where we cannot guarantee the rate of the event occurring being constant over time, then it makes sense to settle for the Weibull distribution. This is Schedulytics. If you like content such as this, we encourage you to subscribe, turn on the post notification bell so you are always notified whenever a new video is released. Until we meet again on our next one, this is Schedulytics, and it's a bye.